Hey everyone, ready to dive into something kind of cool, something that might even spark some new ideas for your research.
I'm ready.
So today, we're doing a deep dive into design build.
Design build DB.
Yeah, DB for short. Specifically how it's used in architecture education. The really cool thing about DB is that it's all about breaking down the wall between theory and practice.
Getting those students out there building things in the real world. Huh?
Hey, before we get ahead of ourselves, let's rewind a bit.
Rewind.
Yeah, like go back in time a little. Where did this whole design build concept even come from?
Okay, I see where you're going. Well, you can actually trace its roots back to some pretty influential figures. Think Bauhaus.
Oh, the Bauhaus. Always a good place to start.
Definitely. That iconic design school from the early 20th century. They were all about merging artistic vision with practical craftsmanship, which aligns perfectly with those core principles of DB.
Totally. But DB isn't just a relic of the past, is it?
You're right, it isn't. I mean, early pioneers like John Ruskin and even Booker T. Washington, they were already championing community-focused building projects.
Really?
Yeah, emphasizing hands-on learning, with a real social impact. And then fast forward to today, we've got digital fabrication, advanced modeling software, all that cutting-edge tech that's totally revolutionized how students approach design and construction.
That's what's so exciting about DB, right?
Yeah.
It's not just about traditional craftsmanship. It's about embracing new tools and methodologies,
Yeah,
really pushing the boundaries of what's possible.
absolutely.
But before we get too ahead of ourselves, dreaming up the future, let's ground ourselves for a minute.
Ground ourselves.
Yes. In the theory behind DB, I'm actually really curious. What are those underlying kind of pedagogical principles that make this approach so effective?
Okay, so at its core, design build is all about experiential learning. It's the idea that we learn best by actively engaging with knowledge instead of just passively absorbing it.
Oh,
David Kolb, that educational theorist, he was all about this. He argued that true understanding actually comes from experiencing, reflecting, conceptualizing, and then actively experimenting.
that's super interesting. So it's a whole cycle that's totally embedded in the DB process.
Exactly. It's not just about that end product. It's about that whole process of experimentation, solving problems, and then iterating on your solutions.
And that makes so much sense, right? Especially when you think about the research process. It's like going beyond theoretical frameworks and actually creating something tangible, something you can test and refine out in the real world. So we know it's about experiential learning. But what kinds of DB projects are out there? Like, what does that look like in reality?
Well, there are actually four main categories that kind of showcase the range of possibilities.
Okay, 4, lay 'em on me.
First, you've got experimental projects, which are all about pushing boundaries, These projects explore new materials or test out new technologies or experiment with totally unconventional construction methods.
Interesting. So it's like architectural R&D.
Yeah, exactly.
Yeah.
Then you've got inhabitable projects, which focus on designing structures that directly benefit communities.
So things like affordable housing units or community centers.
Exactly. Any type of space that's really about improving people's lives. And then there are prototypical projects, which are focused on developing scalable models, for future applications.
So taking research findings and turning them into blueprints, basically.
Yeah, exactly. They often involve testing out innovative design solutions that can be replicated and adapted for different contexts.
Fascinating. What's that 4th category?
Okay, so the 4th category is generative projects, which are kind of more conceptual in nature. They explore design possibilities, push those creative boundaries, and they might not even always result in a fully built structure.
Okay,
They're all about sparking new ideas and pushing the field of architecture forward.
got it. So like the early stages of research where you're just kind of exploring different ideas and asking what-if questions.
Right.
Love that. So we've got these 4 categories, but I'm curious about the methods themselves. Is it all like hammers and nails, or is there a digital side to DB as well?
That's a great question. You'll actually find both traditional and digital methods being used in DB.
Makes sense.
Yeah, some projects definitely still rely on those classic hands-on construction techniques, working with wood, concrete, all that. But digital fabrication is definitely changing the game.
For sure. 3D printing, laser cutting, robotic fabrication, all that.
Exactly. And that's something I think researchers in tons of different fields could really benefit from exploring. Like, how could you integrate those tools into your own methodology?
Yeah, it opens up a whole new realm of possibilities.
It does.
Okay, well, I think it's time to bring all this to life with some specific examples. For this deep dive, we wanted to really highlight the incredible work being done at Beirut Arab University, specifically at their Tripoli campus.
BIU Tripoli campus. Okay.
We chose these case studies because they're amazing examples of how DB can be used to tackle real-world social challenges, something I know you're super passionate about.
Totally. What I find so compelling about those BAU projects is that they just tackle these complex social issues head-on using that hands-on, community-focused approach. It's not just theory, it's about making a tangible difference.
Yeah, exactly. And I think a great place to start is their work on refugee shelters. You know, they really embrace the DB approach to create a really practical and impactful solution.
For sure. The Syrian refugee crisis in Lebanon, that presented a whole unique set of challenges, especially with those legal constraints around building formal refugee camps.
Yeah, totally. But those students at BAU didn't shy away from it. They just dove right in, did a super in-depth analysis of existing refugee camps to really understand the conditions and the needs of the people living there.
Exactly. And then they shifted their focus to that micro-scale design of the individual shelter units. What's remarkable is how resourceful they were. They used locally available materials like sand-filled fabric walls to create these super durable, thermally insulated, and really importantly, cost-effective structures.
It's amazing how they combined sustainable design with practical considerations.
Yeah, and the impact of their work, it really extended way beyond the classroom. Their designs ended up winning international competitions, got recognized by the UNHCR, and even led to the creation of a startup company.
No way. What was the startup for?
To mass produce these shelters.
Wow, that's really amazing. A perfect example of how DB can lead to those tangible, scalable solutions that have the potential to really make a difference, even on a global scale.
It really is.
Okay, the next BAU project we wanted to highlight focuses on street vendor units. Totally different set of challenges, but equally impactful.
Oh, yeah. This one's great. So picture this. The city of Tripoli suddenly evicts all those informal street vendors from the waterfront.
Whoa.
Yeah, leaving a lot of them with no income and no place to do business. It was a really disruptive move, created a real need for some innovative solutions.
For sure. And that's where those BAU students stepped in, using the DB approach. What was their approach?
Okay, so they started by analyzing urban patterns, understanding those really specific needs of the vendors, and even factoring in environmental considerations.
Interesting. So thinking about the bigger picture and the long-term impact.
Exactly. They wanted to create units that were functional, but also sustainable, integrated into that urban fabric.
I love that. So what did they actually end up building?
Okay, so they came up with some really clever solutions, like they incorporated renewable energy into those units through solar panels.
Oh, cool.
And even small wind turbines. The goal was to create self-sufficient, sustainable structures that minimize their environmental impact.
That's amazing. Did they get any recognition for this project?
Oh, yeah, they did. Their efforts got noticed and were actually recognized by the local authorities, which really highlights how DB can be used to create solutions that are both innovative and practical, addressing real-world challenges in a way that resonates with, policymakers.
It's a testament to the power of combining design thinking with community engagement.
It is.
To create solutions that are not only functional, but also socially responsible. And it also kind of shows how DB can be used to empower those marginalized communities. Give them a voice.
Totally.
Okay, so to round out our exploration of these BAU projects, I want to talk about their work on a kinetic facade. This one is a great example of how DB can be used to push the boundaries of technology and design.
Okay. Kinetic facade. I'm listening.
Tell me about it. What was its purpose, and how did they even approach it?
So the project aimed to improve environmental comfort in a government building.
Okay.
But their approach was super unconventional. They ended up using sensors and simulations and even those advanced fabrication techniques to create this responsive facade.
The responsive facade.
Yeah, so it could adapt to changing environmental conditions.
Whoa, that's wild. What were some of the challenges with a project like that?
I mean, it was ambitious, that's for sure. Pushed the limits of what was possible. They had to grapple with some pretty complex technical challenges, integrate different systems, and they had to make sure that facade was both functional and aesthetically pleasing.
So many moving parts. Did they actually manage to install it on the building?
So it wasn't actually installed on the original building, no, but it served as this super powerful demonstration of how DB can be used to create innovative, sustainable architectural solutions.
It sounds like it was still a super valuable learning experience.
Yeah.
Even if the final product wasn't implemented, it really shows that iterative nature of DB, right?
Right.
Experimentation and prototyping.
For sure. And for researchers like yourself, this project really highlights the potential for integrating design and building into research projects, in totally new ways.
Now, we've seen these amazing examples from BAU, but I'm curious, how does this approach differ across the globe? Are there any interesting trends or comparisons, like between how DB is implemented in different regions?
Ooh, great question. You'll definitely find some distinct differences between how DB is approached in the global north versus the global south.
Okay, like what?
Well, in the global north, a lot of those DB projects have a really strong emphasis on social engagement.
Got it.
So they focus on partnering with communities to address their specific needs.
So they're really embedded in those communities.
Totally. They work together to identify needs, develop solutions, and create spaces that foster that sense of belonging, shared ownership. Now, in the global south, you'll often see more of a focus on practical skills development.
Makes sense.
Yeah, which makes sense given that a lot of those regions face those more immediate challenges.
Infrastructure, housing,
Yeah.
resource access.
Exactly. The BAU projects are actually perfect examples of this, right?
Yeah.
They're not just about design, they're about utilizing local materials, understanding those construction constraints, and creating solutions that are innovative but also feasible within their specific context.
Right. So important.
It is.
So it's all about tailoring your approach to the specific needs of your research, basically.
Yeah, exactly. And it brings up an interesting question. Could a hybrid approach, blending those elements from both the global north and south, could that be even more effective?
That is something to think about. A blend of global best practices and local relevance. It seems like DB has so much potential to be such a powerful force for positive change, not just in architecture, but in research across tons of different fields.
I totally agree. It's an exciting field, and I can't wait to see how it continues to evolve and inspire those new innovations. It is.
This has been so fascinating so far. But, gotta ask.
Yeah.
Even with all this amazing potential, DB's gotta have its challenges, right?
Oh, for sure. It's not a magic bullet, There are definitely unique challenges.
What are some of those hurdles? Like, what do students and instructors run into when they're trying to do these real-world projects?
Well, I think one of the biggest ones is honestly funding.
Yeah, funding. Makes sense.
These projects often need materials, specialized equipment, sometimes even skilled labor. All of that can put a real strain on budgets, especially in academic settings.
Definitely. It's not always easy to get funding for projects that go beyond the traditional classroom.
Yeah.
Especially when you're talking about actual construction.
Right, exactly. And then there's a challenge of time management. DB projects usually involve so many different phases, from that initial design to the actual construction. And it all has to happen within, the constraints of a semester or an academic year.
It's a lot to juggle.
It is. And then, you got to factor in those real-world constraints. Weather, material availability.
Those inevitable hiccups that just seem to pop up on construction sites.
Exactly. And let's not forget skill gaps. Architecture students, they're super talented in design, but they might not always have that practical construction experience.
So there's a learning curve there.
Yeah.
Not just for the students, but also for the instructors who are guiding them through the process.
Absolutely.
How do you bridge those gaps?
Some programs will bring in experienced craftspeople or construction professionals to run workshops, provide mentorship. Others will encourage collaborations with students from engineering programs or construction management.
Oh, cool.
It's about fostering that interdisciplinary teamwork, that knowledge sharing.
Love that. So it seems like those challenges can actually become super valuable learning opportunities.
They totally can.
It's not just about mastering design software. It's about solving problems on the fly, adapting to those unexpected situations, and really honing those project management skills.
You got it. Students have to think on their feet, make decisions under pressure, and collaborate effectively to overcome those challenges.
And those are skills that apply to any field, right? Not just architecture.
Oh, absolutely. Those are the skills that employers really look for, the ones that translate into professional success.
So it's like a master class in real-world problem solving and collaboration.
It is.
And the benefits, they extend beyond the individual student too, right? We touched on community impact, But are there other societal benefits that DB brings to the table?
Oh yeah, definitely. DB projects, they often address these really genuine community needs, whether it's affordable housing, revitalizing a public space, or designing a sustainable structure. It's about making a real, tangible difference, leaving a positive mark.
It's about going beyond theory and creating solutions that really improve people's lives.
Exactly. And then there's that whole holistic learning aspect. DB projects, they often involve these collaborations,
Yeah.
between architecture students and those from other disciplines, engineering, construction management, even social sciences sometimes.
So you're breaking down those silos.
Yeah,
Yeah.
fostering that interdisciplinary dialogue, teamwork, and ultimately creating a more well-rounded perspective on the built environment.
Which is something researchers in any field can appreciate.
Totally, that power of collaboration.
Absolutely. So we've explored the challenges, the benefits. It's clear that DB is a powerful approach. But I'm curious about the bigger picture. How do you see DB shaping the future of research in architecture and beyond?
That's a great question. I think DB really has the potential to fundamentally change how we approach learning and knowledge creation in all sorts of disciplines.
In what way?
Imagine a world where research isn't confined to those labs and libraries, but it's out in the real world, where prototypes and solutions are tested and refined in real time.
So it's about making research more tangible, more relevant.
Exactly. And for architectural education, I see DB becoming even more integrated into the curriculum, maybe even starting at the undergrad level.
So less of a specialized thing, more of a core element.
Yeah, exactly. Preparing students to be not just designers, but problem solvers, collaborators, real agents of change.
I love that. So equipping those future architects with the skills and the mindsets they'll need to tackle those complex challenges.
Right.
It's exciting to imagine a future where DB is a much bigger part of research and education, empowering people across all disciplines to create real solutions.
Absolutely. It's about fostering that culture of innovation, collaboration, impact, where knowledge is not just acquired, but applied.
Before we wrap up this incredible deep dive, I want to leave our listeners with one final thought-provoking question to ponder. So, dear researcher, given everything we've discussed about design build, its principles, its challenges, its amazing potential, could this approach be adapted to your own field of research? Could you take your research findings and turn them into tangible prototypes, solutions, even interventions that have real-world impact?
That's a fantastic question. What unique challenges and opportunities might emerge if you embraced a more hands-on, collaborative, and community-engaged approach to your research? What kind of breakthroughs could you achieve?
It's about pushing those boundaries, transforming knowledge into action, and ultimately making a real difference in the world.
It really has been a pleasure, diving deep into this whole world of design build with you.
I agree. I don't know about you, but I'm leaving this conversation feeling so energized.
Energize, yeah.
It's just incredible to see how those core principles of design build,
Yeah.
that hands-on application, community engagement, that holistic way of learning, it can be so powerful, not just in architecture, but in, well, potentially any field.
Right, exactly, where you're trying to create real solutions to real problems.
Exactly.
Absolutely, it does. It